So you need a seagull problem. Okay, here's how you do it. This is the number 6 of C2 from Unit 3. So here's the ground for the seagull problem. And the seagull is 12.5 meters in the sky. Now in this problem, it states that the seagull is moving upwards at 5.2 meters per second. This is your initial velocity. We know that when the seagull releases this shell it's holding at this height, we know the shell is going to move up a little bit and then it's going to fall and plummet down. So what can we do here? We know whenever that shell goes up, it is going to reach a maximum height somewhere. Okay, and there's a few things you know. You know that at maximum height, the final velocity of the shell will be 0 meters per second because it's like hovering, it's not moving for that instant of time. And always what's causing it to slow down and then fall is gravity. So you know the acceleration due to gravity, that's the 9.8 meters per second squared. And since we're calling down negative because up was positive over here, see how that's positive and it's going up, that means this gravity, the acceleration due to it, has to be negative. So now you've got 1, an initial velocity, 2, a final velocity, and 3, an acceleration. And if you can find this distance right here, a delta x, if you can find that delta x and then add it to 12.5 afterwards, that will give you this total distance here, which is technically what part A is looking for, okay? So you need to find this right here to begin with, and then add it to the 12.5. If you're looking at equations to use here, notice you don't have time anywhere, so may I recommend the equation that doesn't use time, which is equation number 6, which is that your final velocity squared equals an initial velocity squared plus 2a delta x. If you're running this, you know the final velocity is 0, you know the initial velocity is 5.2, you know 2, you know the negative 9.8, you're solving for delta x. Make sure that you subtract first, or you square and then subtract it. It's really up to you how you want to do it. There's a whole bunch of algebra here, but you're going to have like the negative 29-ish, I can't remember what that is, and then it's going to be divided by 2 times negative 9.8, which is negative 19.6, to equal delta x. In the end, this should be approximately like 1.37, 1.4 meters. That's what you're looking for here. And then when you add that to the 12.5, you get somewhere around 13.9 meters. Okay. For part B, kind of similar, kind of a little different. In part B, what you want is you want just the time it takes to go up and come back down just to this height, just to that height right there. Okay. So you've got 2 options here for part B. In part B, you can either set delta x equal to 0, and if you do that, then you'll have an initial velocity and acceleration and a delta x, and then you're just solving for a time. Okay, and that delta x is 0 because you start and end at the same position. You can look for time. There's a few other ways to do that. You can like look for it whenever it gets to the top again, find a time there, and then double it. But you know, there's many ways to solve that problem. But that is the rundown on problem number 6 from the C2 Unit 3. And with that, the problem's finished. Adios. Take it easy.